Hey everyone, welcome back to my YouTube channel. What if everything you thought you knew about our solar system was incomplete? What if beyond the familiar orbits of Jupiter, Saturn, Uranus, and Neptune, and even past the dwarf planet Pluto, a colossal, unseen world has been quietly shaping the destiny of our cosmic neighborhood for billions of years? Imagine a planet so massive, so distant, that its gravitational whispers alone betray its presence, pulling at the very fabric of the outer solar system, orchestrating a cosmic ballet of icy worlds we are only just beginning to observe. This isn't science fiction. This is the tantalizing, compelling, and increasingly robust mystery of a hidden planet, a true ninth planet lurking in the dark, icy reaches far beyond Pluto. For decades, astronomers have been tracking anomalies, gravitational fingerprints that simply don't add up. The orbits of distant objects are behaving strangely, as if being herded by an invisible giant. We're talking about a world potentially many times the mass of Earth, a cold, dark behemoth that could redefine our very understanding of home. The implications are staggering. If such a planet exists, it would rewrite textbooks, challenge our models of planetary formation, and deepen the enigma of how our solar system truly came to be. But the biggest question remains: how could something so huge stay hidden for so long? What does its very existence mean for us, tiny inhabitants of a small blue planet, in a solar system that might be far stranger and more dynamic than we ever imagined? The search for this hidden world is one of the most thrilling scientific quests of our time, a detective story playing out across billions of miles of empty space. We're on the cusp of a revelation that could fundamentally alter our cosmic perspective. To understand this cosmic mystery, we need to go back to where it all began, to a time when the search for hidden planets was already a driving force in astronomy. The story of hidden planets, of unseen gravitational forces whispering across the void, truly begins with a whisper of its own: the subtle, baffling movements of Uranus. In the late 18th and early 19th centuries, astronomers meticulously charted Uranus's path across the sky. But something was off. Its observed orbit didn't quite match the predictions based on Newton's laws of gravity and the known planets. It was as if an invisible hand was tugging at Uranus, subtly altering its trajectory. This was a cosmic puzzle, a profound challenge to the very laws of physics, or a clue to something more. Enter Urbain Le Verrier in France and John Couch Adams in England, two brilliant mathematicians working independently in the mid-19th century. They weren't looking through telescopes. Instead, they were sifting through mountains of calculations, using the anomalous movements of Uranus to predict the existence and location of an unseen planet. Imagine the audacity of such a feat. Declare that a world must exist, not because you saw it, but because its gravitational influence was undeniable. The tension was palpable in the astronomical community. Could mathematics alone reveal a new world? In 1846, Le Verrier sent his predictions to astronomer Johann Gottfried Galle at the Berlin Observatory. On the very night Galle received the letter, he pointed his telescope to the sky, to the exact coordinates Le Verrier had specified. And there it was, a new planet, a gas giant, shining faintly in the darkness. Neptune had been discovered, not by chance, but by the power of deduction and the unwavering belief in gravity's reach. It was a triumph of celestial mechanics, a testament to the predictive power of science. But here's where the story takes an unexpected turn, a plot twist that would set the stage for our current mystery. Even after Neptune's discovery, some astronomers noticed that Uranus's orbit still showed slight asterisk discrepancies, and Neptune itself seemed to be experiencing subtle gravitational nudges that couldn't be fully explained. Whisper hadn't entirely faded. The idea of another unseen world, a planet X beyond Neptune, began to take root. The most prominent advocate for this idea was Percival Lowell, a wealthy American astronomer who, in the early 20th century, established the Lowell Observatory in Flagstaff, Arizona, specifically to hunt for this elusive ninth planet. He spent years meticulously calculating, predicting its possible location. Lowell's search was painstaking, involving countless photographic plates, each a tiny snapshot of the night sky. He died in 1916, his planet X undiscovered. But his legacy, and the mystery he pursued, lived on. Years later, in 1930, a young, self-taught astronomer named Clyde Tombaugh, working at Lowell Observatory, took up the mantle. His task was monumental: systematically compare photographic plates taken days apart, looking for anything that moved against the background of fixed stars. It was a tedious, eye-straining endeavor. Day after day, week after week, Tombaugh meticulously scanned the plates using a blink comparator, a device that rapidly switches between two images, making moving objects appear to jump. And then on February 18, 1930, after nearly a year of searching, something did jump. A tiny, faint point of light shifting position. Clyde Tombaugh had found it. The world rejoiced. Planet X, soon named Pluto, had been discovered. The solar system, it seemed, was finally complete. Or was it? For decades, Pluto reigned as the ninth planet. But as astronomers learned more about it, a new problem emerged. Pluto was tiny. Far too small, in fact, to exert the gravitational influence needed to explain the orbital anomalies that had initially spurred the search for Planet X. The discovery of Pluto was a monumental achievement, a testament to human perseverance. But the underlying gravitational mystery, the one that had started with Uranus and persisted even after Neptune's discovery, remained unsolved. Pluto was a magnificent find, but it wasn't the giant, hidden world astronomers had originally envisioned. The ghost of Planet X, a truly massive, unseen perturber, still haunted the outer solar system. This was the cosmic equivalent of finding a small pebble when you were searching for a mountain. The hunt for the real Planet X, a world capable of bending the orbits of giants, was far from over. And as we would soon discover, the evidence for such a world was only beginning to reveal itself, leading us down a rabbit hole of astronomical intrigue. The investigation deepened considerably in the late 20th and early 21st centuries, thanks to more powerful telescopes and systematic surveys of the outer solar system. We began to discover a vast, icy realm beyond Neptune, a region we now call the Kuiper Belt. This is a donut-shaped disk of icy bodies, a remnant from the early solar system, much like an asteroid belt but far larger and colder. The first Kuiper Belt object, or KBO, was discovered in 1992, and since then, thousands more have been found. But it was among these distant, icy worlds that the most compelling clues to a hidden giant would emerge. Imagine you're watching a flock of birds, and you notice that a small group of them, at the very edge of the flock, are all suddenly veering in the same direction, as if being guided by an unseen force. That's essentially what astronomers started to observe with a particular subset of KBOs, known as extreme Trans-Neptunian objects, or ETNOs. These are objects with orbits that take them incredibly far from the sun, sometimes hundreds of times the Earth-Sun distance, and they spend most of their time in the darkest, coldest reaches of our solar system. Here's where it gets weird. In the early 2010s, astronomers noticed something truly peculiar about the orbits of several of these ETNOs, including well-known objects like Sedna and 2012 VP-113. Their orbits weren't just long and elliptical, they were clustered asterisk. Specifically, their perihelia, the point in their orbit where they come closest to the sun, were all pointing in roughly the same direction. And their orbital planes, their tilt relative to the main plane of the solar system, were also oddly aligned. It was as if these distant, independent objects were all being gravitationally herded, or shepherded, by something massive and unseen. This wasn't just a couple of objects. As more ETNOs were discovered, the statistical significance of this clustering grew stronger. It was like finding multiple needles in a haystack, all pointing in the same direction. What could possibly be causing this bizarre alignment? This anomaly couldn't be explained by the known planets. Jupiter, Saturn, Uranus, and Neptune are powerful, but their gravitational influence diminishes significantly at these extreme distances. It was a genuine cosmic plot twist. The conventional models of our solar system simply couldn't account for this observed clustering. Scientists were faced with a paradox. Either our understanding of the outer solar system was fundamentally flawed, or there was something else out there, something big, pulling the strings. In 2016, astronomers Konstantin Batygin and Mike Brown at Caltech, building on the work of others, formally proposed the Planet 9 hypothesis. They weren't just saying there might be a planet. They were providing detailed simulations showing that the observed clustering of ETNOs could be explained by the gravitational influence of a massive, distant planet. Imagine a planet roughly 5 to 10 times the mass of Earth, orbiting the sun at an average distance of about 500 to 700 astronomical units. That's 500 to 700 times further from the sun than Earth is. This hypothetical Planet 9, they argued, would gravitationally sculpt the orbits of these smaller, distant worlds, effectively herding them into the observed alignment. It would also explain the strange, highly inclined orbits of some of these objects, tilting them out of the main plane of the solar system. This wasn't just a wild guess. Batygin and Brown's models made specific predictions about Planet 9's characteristics and its likely orbital path. This gave astronomers a target, a blueprint for the hunt. The excitement was immense. This wasn't just about finding another planet. It was about uncovering a fundamental, missing piece of our solar system's architecture. The very thought that a world potentially larger than Earth could be hiding in our own cosmic backyard, undetected for so long, is mind-boggling. The sheer scale of what we are talking about is hard to grasp. If Planet 9 exists, its orbit is so vast that it would take thousands of Earth years to complete a single revolution around the sun. For most of its immense journey, it would be a cold, dark, incredibly faint object, reflecting very little sunlight, making it extraordinarily difficult to spot. This is why it has remained hidden, a ghost in the cosmic machine, for so long. The evidence is indirect, based on gravitational whispers, but those whispers are getting louder and more insistent, teasing us with the biggest revelation yet to come. The modern quest for Planet 9 is a testament to humanity's insatiable curiosity and our ever-evolving technological prowess. We're no longer relying on blink comparators and photographic plates. Today, astronomers are using some of the most advanced telescopes on Earth and in space, pushing the boundaries of detection to their absolute limits. Observatories like the Subaru telescope in Hawaii, with its massive 8.2-meter mirror, and the PANAS-DARRS telescopes, designed for wide-field surveys, are systematically scanning vast swathes of the sky, looking for the faint signature of a distant, moving object. The upcoming Vera C. Rubin Observatory, formerly known as the Large Synoptic Survey Telescope, or LSSD, with its unprecedented wide field of view and rapid survey capabilities, is expected to revolutionize this search. It will repeatedly image the entire southern sky, creating a massive dataset that could finally reveal Planet 9, or at least significantly constrain its possible location. The search isn't without its challenges and its scientific battles. While the Planet 9 hypothesis is incredibly compelling, it's not the only game in town. Some astronomers argue that the observed clustering of ETNOs could be due to observational bias, that we're simply more likely to discover objects whose orbits happen to align with our viewing angles. Others propose that the combined gravitational effects of many smaller, undiscovered Kuiper belt objects could mimic the influence of a single large planet. And then there are the truly exotic theories, like the possibility of a primordial black hole, roughly the mass of Planet 9, lurking in the outer solar system. This idea, while far-fetched to some, highlights the truly mind-bending possibilities when you're dealing with such extreme unknowns. The debate is healthy, a vibrant scientific battleground where theories are proposed, tested, and refined. Each new discovery of an ETNO, each new observation that either strengthens or weakens the clustering argument, adds another layer to this cosmic detective story. For example, recent analyses have refined the statistical significance of the clustering, making it harder to dismiss as mere chance. Imagine the thrill of these astronomers, poring over data, running simulations, knowing that they might be on the verge of one of the greatest astronomical discoveries of our time. The sheer scale of the search is immense. You're looking for something incredibly faint, moving incredibly slowly, across an area of space so vast it dwarfs anything we can easily comprehend. Think of trying to find a single, unlit candle in a football stadium from miles away on a moonless night. That's the challenge. Yet the tantalizing clues continue to mount. The precise orbital characteristics predicted by Batygin and Brown's models are remarkably consistent with the observed anomalies. If Planet 9 is found, it will be a testament to the power of indirect evidence, of inferring the unseen from its profound gravitational effects. The very act of searching, of pushing our instruments and our intellect to their limits, is expanding our understanding of the outer solar system in unprecedented ways, revealing a region far more dynamic and complex than we ever imagined. The climactic revelation, the first direct image or undeniable detection of this hidden world, is what every astronomer involved in this quest dreams of. It would be a moment that echoes Gala's discovery of Neptune, a triumph of prediction and observation, a confirmation that our solar system, our cosmic home, holds secrets we are only just beginning to unlock. If Planet 9 truly exists, its implications for humanity's place in the universe are profound. It would mean that our understanding of the very neighborhood we call home has been incomplete for centuries, that a major component of our solar system has been hiding in plain sight. This isn't just about adding another dot to a map, it's about fundamentally redefining our cosmic address. It would force us to rethink how planetary systems form and evolve, challenging existing models and opening up entirely new avenues of research. Could other star systems also harbor such distant, hidden giants? The discovery of Planet 9 would be a powerful reminder of the vastness of the unknown, even within our own solar system. It would fuel our existential questions. What else is out there? How much more do we have to learn about the universe, even in our immediate vicinity? This discovery could also ignite a new era of exploration. Imagine future missions, perhaps decades from now, designed to visit this cold, dark, distant world. What would we find there? What secrets of the early solar system might it hold, preserved in its icy depths, untouched by the warmth of the sun? It would be a scientific goldmine, a pristine laboratory for studying planetary formation and the conditions for life in extreme environments. The prospect alone is enough to stir the imagination and inspire a new generation of scientists and explorers. The quest for Planet 9 is far from over, but the tools are getting sharper, the surveys more comprehensive. The Vera C. Rubin Observatory is expected to be fully operational in the next few years, and its continuous sky surveys could provide the breakthrough. Other future missions, perhaps even space-based telescopes designed for infrared detection, could offer a clearer view into this frigid realm. The anticipation within the scientific community is immense. You're living through a golden age of astronomy, where the impossible often becomes possible, and the unseen is brought into focus. So, we circle back to our initial cosmic mystery, the strange, inexplicable dance of distant icy worlds. The anomalous orbits that first hinted at something massive, something hidden, are now coalescing into a compelling narrative. The evidence, though indirect, points overwhelmingly to a giant, unseen world, a true ninth planet that has been shaping our solar system's architecture for billions of years. Its existence would not only add a new member to our planetary family, but would profoundly alter our understanding of how our solar system formed and evolved. It reminds us that even in our own cosmic backyard, the universe continues to hold mind-bending secrets, pushing the boundaries of our knowledge and fueling our boundless curiosity. The search for Planet 9 is a testament to the enduring human spirit of exploration, a journey into the unknown that promises to redefine our place in the cosmos. And as we gaze up at the night sky, we are left with a powerful, lingering question. What other giants, what other mysteries, are still waiting to be discovered, silently orbiting in the endless darkness just beyond our reach? Thanks for watching. Subscribe to my YouTube channel.